So I'm going to have to completely wing this week. It's been a hell of a day. I'll just make it up as I go along, right? So we covered quite a lot last week. I mean, I said that week three was bad in the sense of going from simple neural networks to CNNs and GANs in an hour. But actually, I looked over last week's notes, and there's a lot of stuff in there as well. So I was going to recover some of that, potentially with questions from the audience. Then I was going to, probably with the help of the whiteboard or the note stand, start to think about what a recipe for designing a data-enabled business would look like. And then, depending on how fast or how slow we go through that, I've got one of the case studies from Simon Wardley's stuff. It's chapter 12 of the book that's online. It's called The Scenario, which is looking at a particular business and one that becomes data-enabled and thinking about strategy in the context of sort of gameplay. So we'll see how we get on. So this is where I ended week 4 as the sort of setup, right? So we're looking for patterns in data. We model those patterns. We end up with some predictions. We can think of this as a slightly quasi-academic stroke scientific exercise. In principle, because we're going through the processes of trying to understand what's in the data. But invariably that turns into a sort of iterative process trying to understand a particular business problem, because the data itself might not necessarily support the first sort of analysis that you want. So we go through an iteration, and that was the sort of top part of the CRISPR cycle. And then once we get something that we think we're happy with, i.e. we think we understand the business problem, we think we understand that the data that's being collected by the business can support the analysis we want, we have to get that into production. So we have to push an engine as an instantiation of a model out into the world, and we have to get that to interface with the business. So normally we think about an application layer, something that's using the output of that prediction. And in certain cases, that might be all within the application itself. For example, I've got a piece of software that does everything from start to finish. It collects the data, it processes the data, it has a model inside the application, and that application itself does some sort of predictive process for you. And that's the way that machine learning has been used to date, really. In the sense that there are lots of what you might think of as smart applications all over the place using machine learning, but they're done at the level of the app, right? Whether that's something on your phone doing predictive texting, so that one of the early transitions to smartphone was really enabled by machine learning, because they couldn't get the keyboard to work on the iPhone, because people kept on the first version of the keyboard release, the accuracy with which you had to use your fingers meant that you could never type on it, because they got rid of the buttons thinking that the screen would work, but actually then the accuracy on the screen wasn't high enough, and so people in all of the early prototypes were hitting this thing, and they even had to get to the point of nearly shipping it, like with the keyboard still not working. And so they sort of went back to square one in the Apple labs and said, right, okay, if we can't get the buttons working, we can't get the screen working, how are we going to get people to be able to actually use this thing? And so what they do is they end up with a sort of machine learning algorithm that predicts where it thinks your finger is trying to get to correct the signal. So we're used to actually those smart applications having been around a long, long time. And if we think about something simple like k-means clustering, there are all sorts of applications that are being used, very simple, for things like document retrieval, what have you, and they've been used for decades now. So it's not really new in the strong sense of the word. What is new, though, is starting to think about whole businesses as just collections of deployable models, right? So we talked a little bit last week about, thinking about identifying aspects of a business that are designed around poor prediction. But the example was the airport lounge, right? Buffering, right? Not being able to predict the arrival of people means that we've created an industry, right? We've created a commercial sector around buying things in airport lounges because we couldn't predict their arrival particularly well. And the challenge is trying to understand in an incumbent business how many of your existing processes are because you can't do prediction very well. And if prediction becomes much better and much cheaper, then you can start to restructure businesses around that. And so that does start to look a little bit different from where we've been previously. So, if you start to break a business apart in terms of systems and systems that just connect through APIs and interfaces, then you could start thinking of replacing large bits of systems with, engines of one sort or another, right? I get this type of business, this type of input into my business at this stage. I get this kind of output. And at the very end of last week, I started to put up something that looked like, where'd it go? Oops, ignore all that. Started to put up something that looked like this, which was a Wardley map of a sort of a pretend business. And we could start thinking about what applications we have within a business and how they interface and what data might support it, what infrastructure in terms of sort of databases or data lakes, etc. And the bit that's sort of new in designing sort of data-enabled businesses is perhaps these two layers, thinking about data collection and data storage in a much more systematic way than we perhaps have done. It's not just a CRM. And then thinking about how you might be able to deploy, engines or predictive systems for various parts of your business. So to get back to that, just to sort of reiterate some of the slides, what we just talked about there is this kind of this modeling process, and that is at the top part of the CRISPR cycle. The CRISPR cycle is this data mining type thing, but iterating between business understanding and data understanding to the point where we've framed the problem in a way that we think works. And don't underestimate that. This is those first three boxes, those first three circles are probably 80% of the effort involved in a project. This bit's the easy bit. Then we do some sort of modeling cycle, and then we spit it out. We either get performance we don't want, or we manage to deploy it. And I suggested that you could think about that in the context of something like a business model canvas. So we broke the business model canvas into sorts of conventional 9 boxes. We had the ones at the top, which were customer segments and relationships and channels, the value proposition, and activities and resources. And I said we could expand that in a kind of domain-specific way, in this case, a technology-specific way. And I showed you an example of a machine learning canvas, which broke down the problem into the problem of designing a machine learning system into, again, 8 or 9 boxes of things you might want to think about. And the CRISPR cycle sits on top of it. So the top part is this business understanding kind of cycle. And we talked a little bit about feedback. We talked a little bit about judgment, or the role of judgment in a predictive system. So we took apart the decision process in terms of input data and a predictive process and an outcome and a feedback mechanism for learning and the role of judgment. And we talked a little bit, if you think back to week 4, where we were thinking about ensemble systems, we had ways to stack up technical predictive systems to make them work a bit better. There's a very blurry line between the original predictive system, trying to do whatever you wanted to do, versus a system that regulates or sits on top and therefore provides judgment about when you should trust or not trust the output of this system, because we had things like stacking or boosting. But in most of these systems, somewhere there's going to be a human in the loop saying, like, in which scenarios do we believe the machine versus we don't believe the machine, and can we deal with them? Then this sort of cycle is what we discussed a little bit in week 2, effectively. We did an end-to-end kind of problem where we cleaned some data, looked at the different steps in the pipeline, but we didn't really get to deployment. And then we discussed a little bit last week about how you would get out into production, what it would look like. I think the important bit here is separating the sort of the metrics that you might use for the engineering side of the machine learning, in terms of like the absolute performance you want on a predictive process and things you want from a sort of standard piece of IT, right? Uptime, mean time to recovery, versus the kind of business side of the performance, i.e., is it producing, better LTV calculations for my customers, or am I getting longer engagement through picking the right content or whatever it happens to be? So those were the 3 parts of the process, and I realized I sort of put them up without having a slide that linked all the aspects together. And I still haven't produced one, but I did produce a sketch, which I was intending to turn into a real slide, so I thought I'd put the sketch up. And what we've got here is we had like the original business model canvas, right, where we've got a particular activity or a particular resource we're trying to do. And then if it's a machine learning system, we could go to something like a machine learning canvas, which breaks out that particular activity of, say, designing and deploying that system in more detail. And ultimately, we can sort of think about these things as an expanded canvas, so that you can put them back together and see this particular domain-specific canvas in the context of everything else it's got to deliver, right? I didn't really have that slide. Yeah, so that on the business model canvas, that's activity, right? The activity might be make a credit assessment. Let's pretend it's a bank, right? It's a business model canvas of a bank. Like, one of the things I have to do for onboarding the customer is to do KYC and AML, and I might want to do creditworthiness, right? And at the moment, my business process is the person gets given the original documents, or whatever it happens to be, and now I want to automate that process. So then I might take that activity that sits in that level of a kind of business process analysis framework, and I might try and drag that out, right? Okay, where does the data sit? Who looks at it? What's the training set? How frequently do I have to do this? Yada, 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 yada. Right? And in principle, if we were going to get into the details of this, we would want to be able to get away from a canvas model, which is just a structured list of things that we need to remember to think about, to something perhaps that looks a little bit more like a Wardley map. And we sat through the Wardley map, and I showed some examples of it, and I've got some much more detailed examples, but I didn't actually show you the sort of the cheat sheet to get between one and the other, or I don't think I did. So that's your business model canvas as it's normally displayed. But if you rotate it, if you turn it on its side, and then it actually lines up with the structure of the map. I think I did go through some of this, right? So you've essentially got customer segments, or your user needs at the top of the graph. You've got a value chain, which goes through things like what's the channel to market, what are the sets of activities and the sets of resources that might have to support this business, all the way down to partners, let's say third party sources of data or something. This is a business we're going to look to in the scenario case study, so I might as well explain it now. The case study is around a company that provides data center services. It tries to make your data center more efficient in terms of thermal energy, etc. When I started teaching this example that Simon came up with, in classes, it was sort of completely contrived in some sense, right? It's not necessarily a real company. But then Google came along and developed a product that did it. So now I can teach it as a Google case study, which we'll get to. Anyway, an easy, if you're struggling to come up with your first version of the map, start with a business model canvas, which basically most people can get to grips with, and then it turns out that you can just build them. So they're very similar. So here I've split it out top to bottom. Your value proposition tends to be a sort of a collection of the key nodes on the graph. And what's required to deliver that specific value proposition. And then you can build out the graph by thinking about other things on there, right? So we can put in, channels to market, i.e. resellers, or customer relationships in terms of, software licenses, etc. We can build up some of the support functions or delivery functions, right? We need a sales team, even if they're going to go through resellers. We can build out, for example, here at the bottom, a bit more of the engineering, right? So we've got the client has a data center, wants to know how efficient it is, wants to be able to improve the efficiency of it. There is some system logic which allows us to alter the behavior of the data center. That is based off the sensors that the data center is instrumented with, and we've got some other data to do with other things going on, let's say ambient temperature, et cetera, et cetera. So you can see how you can start to build it up. And if you've got two options here, right? Either you are an incumbent business that is looking for a strategy to be able to redevelop some of its existing systems or replace some of its existing systems, in which case you should already start with a very detailed map because you've got a whole load of incumbent kit in place that is supporting the current process. Or you're a startup and you don't have any of this in place, in which case we'll start with the incumbent, which is how things are currently done to the best of your knowledge. It's a lot easier drawing these maps when you're inside a business and you know actually what's going on, right? It's a lot harder to try and sort of pontificate or try and create what must be going on under the hood of someone else's business. And also then we talked about the fact that this could be split into sort of profit and loss type accounts. So you've got certain branches of this map. Between those are going to produce revenue. Some of them are going to spend revenue on terms of unit price for delivery. And I was going to go through that in a bit more detail. So I think that's a slide that I have shown before, but I don't know that I've shown this one in terms of breaking it out as an easy way to construct it.
Is there any rule of thumb to understand how much detail should go on the body map? Because on one side it's more like you can be quite broad and very high level, on the other side you can add so many things in it from a business perspective.
Well, so that's why I think doing it at the right. So yeah, there is a level of abstraction. Okay, I did sort of draw this diagram, but obviously a canvas model can be done at various levels of abstraction, right? So if we imagine we were just in an engineering team, all right, we're right at the bottom of the stack. We've got dealing with a whole load of things. Almost all of your canvas is going to involve stuff that's internal to the business. You're just going to be looking at systems. By the time you get to the top of this stack and you are kind of C-suite, you're for most of the time going to be worrying about stuff that's as much of your time is going to be spent dealing with stuff that's external to the business, right? And in Osterwilder's framework, you go from the business model canvas to whatever that third canvas he produces is that looks nothing like a canvas model, right? He's almost got like sort of Porter's 5 forces scattered around. Like, what do I have to worry about? I have to worry about market. I have to worry about regulatory environment, etc. Yeah. Dun, dun, dun. So in this pretend world, we've got these various, very complicated canvases that have got all sorts of different systems in, right? They've got, yes, you've got machine learning and data systems, but you could have telco systems, right? You could have anything that you can put in a value chain, right? Your agricultural business versus your transport business versus your telecoms business have all got completely different underlying things. And at the bottom of this stack, it'd be very complicated. And as you go up this level of abstraction, you get back to the business model canvas, which you might as well think of as the most basic business model that can do anything useful, right? You've only got 9 nodes or 9 boxes. So the answer to your question is you need to tackle that problem at the level of abstraction that's most appropriate for the analysis, right? And so you can draw a Wardley map for a specific part of a business. You could draw a Wardley map for a whole business. So the answer is to frame the value proposition. Again, that's why the business model canvas is a good way to abstract, right? Okay, what's the value proposition here, right? It could be a customer, but it could be an internal user, right? Anything that you put on your description of the problem, how do I make this work again now? Anything you put on your initial description of the problem, in this box, is going to define the level of abstraction that means you construct the map, which is why I think it's useful, right? Because one of the first things you do when you start drawing these maps is you're like, well, where do I put this node, right? And I end up, you start drawing them in, and all of your components are in the top right-hand corner or something, right? And you've got this whole map. So again, if you're starting out doing this, start with the business model canvas. It will roughly align the top node on the graph is your anchor is going to be your user. The give or take, the bottom, we talked about outsourcing structures, right? This area of the graph is going to be things that you are consuming from third parties and therefore are likely to appear on the partner list inside that. Does that make sense? And I think, and the same goes for the machine learning canvas in terms of level of granularity, right? You're going to pick off the business problem, the decision that the business is trying to make, and that decision, that business decision, is going to frame the context of the other things that need to be put in place, right? If the business decision is how do I resource and distribute my staff or available resource over projects, is going to look very different to, how do I automate the financial guidance to my shareholders, right, based on stock price, or whatever you worry about at the very top of the pyramid.
Have you seen any shortcomings of Wardley maps?
Yeah, lots. They're quite difficult to get going with, principally, right? The learning curve's higher. And there's all sorts of stuff that they can't really show. In the sense you've got to build the complexity of the language you're using on, right? How do you do size of market? You could make things bigger and smaller. You could turn it into 3D and have bar graphs on it, blah blah blah, right? It's just a level of abstraction that's useful for discussing whatever it is you're trying to discuss. In this context, strategy around value chains, and this is just to elaborate a little bit. So you can think of this as a sort of P&L. So I'll walk through this in a little bit more detail. So in the online version of this, I think it is chapters 7 and 8, possibly. I gave you 2 chapters as a sort of required reading, which was to get us off the ground, right? But obviously there's a whole book online, so you can read as much or as little as you want. But in chapter 7 and 8, they give this example of a large format printing company. And they'd start to work through. So I'll walk through the flow or capital expenditure in this just briefly. So this is the business. It is a company that produces. This is not to do with specifically machine learning, right? This is just to understand another facet of the map, right? But this is a printing business where the client wants to basically do upsell on large printing formats. So rather than you just buying a brochure, you can buy the A0 wall plan or whatever it happens to be. So the value chain is, ignore the top bit. You've got a customer wants to find out about what products are available. There's a microsite that gives you product information. And not only do they want to find out about what products are available, but in this instance, they are allowed a certain amount of test examples. So you can, I will send you register your interest, and I'll send you an example of the quality of printing. And so they need access to a sort of test printer to say, like, give me an example of this printing. There's a testing application, there's some platform, blah, blah, blah. Then there's the normal printing chain, which is just sending out the brochure through the postal service, and then there's this new experimental large format printer. So it's being fed by toner cartridges, and we can think about the metrics or the financial metrics associated with that. So we start with the things that we want to measure. So we're interested in getting either better LTV from an individual customer because they order more of the large format product. And so we've got visitors to the microsite, the number of visitors that hit the microsite that convert into ordering test brochure. We've got the number of visitors that go directly, so they're not going through the product side of the website. Then we've got costs associated with doing that, right? So every time someone hits the microsite, we've got an amortized cost of standing up that web service. We've got the actual cost of printing, and we've got the cost per unit for distribution. And really, that's in the same way that I showed you on the P&L, right? That's a flow of capital. So we can start to pull apart these graphs. Another way to think about it is to pull apart the graph in terms of what does the revenue structure look like, and we can start to instrument. And the reason I'm giving you this example is, one, the capital flows don't have to be money in this kind of analysis. They could be information, or in the context of this, data. It gets you to start seriously thinking about how you componentize a business, right? And one of the things we're going to see, who's read the shareholders memorandum of Jeff Bezos about APIs? Really? Okay, that needs to go in the required reading then. So there's a very famous, although obviously not that famous, shareholder. It's not a shareholder note. It's a note to the company. Yeah. And he lists sort of 8 things around how to restructure the. What date is this? It's famous enough that someone knows what I'm talking about. It's a long time ago. Yeah.
Sign up for this project or leave the company?
It's basically we want to move Amazon onto a service-oriented architecture. Right, it's like 2003.
It was like 10 years ago.
Yeah. Maybe more.
Like the whole API business, they use it for internal purposes.
Quite. Eat the own dog food. So he basically said, if you're any engineering team in Amazon has to interact with any other engineering team simply through APIs. And if you can use any technology you want, but if I find you sharing information or the output of your business unit that isn't through an API, I will fire you. And so Amazon is a long, long way ahead of this curve because they've done it a long time ago now, which is completely componentizing the delivery mechanisms within teams. And if you start thinking about a business as a distributed set of units, then you can start swapping out the technologies that are in any one of those components, and you can upgrade them, and you can also start to do very clever things with data, right? Because all of the input to any of these, let's pretend we've got a finance team, right? Finance team is just collecting data, which is the output of activity from the other teams, etc. And if you get into, not if you get into the habit, right, but if you start to institutionalize that change at a business unit level, then swapping out various components of that for predictive engines of one sort or another becomes very, very easy. Slightly digress. Another trick. So I showed you the first trick, which was to construct the map using business model canvas as a way to get the level of abstraction right and select the sorts of components that we're thinking about. Another one is this idea of a spot diagram. So we take an existing business process flow, and that could be something that's literally horrific, right? It could be thousands of nodes on a graph. For those of you that work in sort of traditional businesses, and we can start to label it based on what we believe to be the maturation of the technology or the delivery of the component. So we can reorder the original business process diagram essentially into something that looks more like that as a way of bootstrapping. And then we'll come back. I'm going to leave that because we're going to do gameplay on the original example. And so those flows can be thought of as also just a P&L. So I'll go through that in more detail. Here I'm doing it for a cup of tea, which is an example Simon has, but I realized that this is a picture from the FT from about 2 weeks ago on the breakdown of the structure of costs of a cup of coffee. Right? So it's still a very relevant process. So here's a pretend company that produces cups of tea. We start with revenue at the top. We've got the cost of sales. We've got general and administrative. We've got an operating profit. We've got some income at the bottom. And we can see how we would start to put that down. So we've got exchange of capital between nodes on the graph, which all turn into incremental flows. This is done for capital, but again, this extends to structure of APIs in a data design business. And if you have started to do this map, again, this is a slight sidetrack, but this is where you start to understand, you can start to see peculiar systems, right? In this case, why am I spending a lot on a custom-built kettle when I should just have a productized kettle? Like, we could pretend this is a business like, I don't know, who would have a productized kettle? A boutique bar in Soho that does, what do kids drink these days? Cold press something, I don't know, whatever it is, that I haven't cottoned onto yet. But you can imagine that part of their brand is that they've built this special coffee. And so therefore it's a large outlier in the sense that it looks like a peculiar part of the value chain. So you could say, well, actually, no, we do need this. This is part of our, you go back to the question about abstraction, like when do I bring in the marketing department or where do I bring in brand value? Well, I'll put it in there because it will justify why I'm building my specialist kettle. And then we can start to do some simple things like, okay, now let's talk about automation, right? Turn all the staff to robots, which is the beginning of the era we're living in, right? We don't need all these people. We're just going to automate them. So what does designing a system look like? Let's pretend we've got a map of our business. Let's pretend we understand a little bit about the structure of the value chain, and we might even understand a little bit about the value of the nodes take to deliver. If we're going to think about automation seriously, how do we go about it? So who's seen this before? Someone that's seen it before, describe the not this versus this version of an MVP.
The MVP wants something testable and demonstrable versus doing the whole thing?
Well, doing the whole thing is good, not versus doing the whole thing. We want something that is a whole thing as opposed to a peculiar slice, right? So we have to build. The logic is if we're going to start doing an MVP and a
It's like your Carlo diagram, isn't it? Your slides at the top, your basic base.
yes,
It's a bit like Photoshop. Most things edit images, but you have some bits, but we have the delighter at the top.
delighter indeed. Although I haven't heard the Photoshop analogy before. Sorry.
This is a constraint optimization scenario, isn't it? You have limited resources, limited time to.
Yeah, it's that the first version of your product you'll build has to be I think there's another good slide which is showing the MVP of the car is not the car.
Skateboard, cycle, car.
Well, this is the skateboard cycle car, right? The development of the MVP. The MVP for the car is the skateboard, right? The MVP for the car is not the shell with no wheels on bricks, right? It has to be able to drive. And so when we're thinking about designing, a machine learning system, the advice is the machine learning system is not the data science project that sits there and does nothing. It demonstrates it's feasible, but it's not valuable, not usable, not delightful, right? The MVP of a machine learning system is something that does a little bit of all of these things, right? And what does that mean in the context of what we've covered so far? It means that you need to have got through that CRISP cycle, which has disappeared right up at the beginning. So, to a certain extent, this part shows that it's viable, right? But it doesn't show that it's useful or delivers utility, right? So we have to get all the way through this, probably a couple of times, and most importantly, we have to deploy. It has to be used. And so we should be thinking about the MVP for our machine learning system isn't a peculiar set of data scientists sitting in a cupboard cranking through some data. It's producing, the most basic usable thing that can get in front of people for that particular business use case. So the machine learning part of it might not even really be there, right? The machine learning part of it might be a human, clicking yes, no, right? But you start to build the interfaces that the business can rely on, and you start to change the business processes such that you can replace the human in the loop with a machine at some point. And a lot of, I wouldn't say all, but a vast majority of startups that are machine learning startups are companies sitting with Amazon Turk in the background, right, giving data to humans so that they can label it, so that in the first use of the product, they get back the answer that the humans are giving them. And then over time, let's bootstrap for 18 months, you start to replace the machine, the humans that are sitting there doing the grunt work in the background with a smarter, quote unquote, algorithm. Who read the 150 pages or whatever of the AI report came out this week?
Read the titles.
Say again? You read the titles? Completely, I'm having a mind blank. What's the name of the guy for people that haven't? Nathan.
The one who runs that.
Yeah.
Something.
The company's called Race, isn't it? Well, the
It's a small conference in third year this year.
Nathan. I'll send this. I can't believe someone else in the room.
Nathan Berry. No.
No. Yes, that's the one. Nathan Benage. So who's read that report? Anyone? Who's scanned read it other than the titles? Yeah, 2 people. I mean, you'll feel interested in this stuff. You should, it's come out this week. You should read it. Actually, there was a question at the end of last week's talk about. It was about mailing lists, wasn't it? So people that I read regularly would be, well, I guess not Nathan because it's only produced quarterly or annually or something. But that tends to be a good report. And the reason I mention it now is because there was a whole slide on label farms in China and India, right, using low-cost workers to label data for you. So you take your Western startup, this is the new version of outsourcing, right? Label outsourcing. Take in the request, send the data somewhere, get a human to do it, send it back. It's come back as labeled data. So Nathan's stuff that is produced is very good. Azim Azar's weekly newsletter is... Yes, Exponential View. Jack Clark, I don't think it's got a name, but he is head of policy for OpenAI. His thing is quite good. Did I mention one other one? I think it was one other one. Anyway, if you want to try and stay abreast of these things, I say try. Benedict Evans, from the back of the room, thank you, is another good one. Sorry, say that again? I don't personally, but yeah, I mean, your Sunday fills up with it. I can't take more than 3 newsletters, right? Like they put like 15 bullet points in each, so suddenly there's 30 things or nearly 60 things to read, and I just try and pick out. I kind of scan read them and try and pick out 3 or 4 each week to read at the weekend. Anyway, so an MVP in this context is a system that's end-to-end, right? It's not a side project. So if we look at our system end-to-end, even if we swap out an engine for people to do it, it's an interface of some description, an application that people can use, i.e. it's returning data to someone or triggering another process. It is capturing that data from that interface at source and storing it somewhere. And we'll come back and talk about storage in a bit. It is the beginnings of the process of automating the actions based on that data, and it is standing up on some sort of infrastructure, even if that infrastructure is Excel spreadsheets, right? But the point is to get all the way through that. What's version 0 of doing this? How do you start to build understanding within your organization? You need to have a lot of these nascent projects going on. And some of them can be aimed at a kind of human software boundary, right? What do we currently get humans to do? Well, things like disruption recovery, etc. What could we automate? This is quite kind of IT-based example, but it might be that there's a whole load of stuff in businesses that is just someone checking, compliance that 3 or 4 things have been done, right? And so what would automatically checking that the 3 or 4 things have been done look like from an automated perspective? Can we get from the human side of the line to the software side of the line? That's your kind of the first easy projects. So efficiency and effectiveness and efficiency. And you could do things like, for every node on that Wardley map, you could start to do, say, a task list or something, right? And how long does that task take to complete, right? If it takes a person a couple of hours to do it, then it makes it quite a good candidate to tick off the list of something that we should look at automating, right? If it takes you a week to automate it or a month to automate it, but everyone's doing it for a few hours a day, then ultimately it's going to save you a lot of money. The first thing, anecdotally, the first thing we did in the law firm is start to automate the time recording process. So in the law firm, bill by 6-minute intervals, and everyone has to fill out a time card basically on what they worked on for what client, for what project. And it probably takes everyone in the firm about an hour a day. And by the end of this year, they won't spend that hour, which if you had that over the year, because it's going to be done automatically by a machine that looks at the applications and looks at things like the email subject lines, and it says, well, based on this, you were probably working on that, right? We've got it to about 80% accuracy now. And so suddenly you're getting back, over the course of a year, thousands and thousands of man hours from that one particular task, right? That might be a little bit kind of lawyer specific. But so the first thing would be thinking about the tasks that happen at an application layer, and how long those tasks take, and then obviously ranking them, how easy they might be to automate, and you can't necessarily do that alone. There's a kind of backwards and forwards between business understanding and data understanding, with a little bit of understanding about what the engine might actually do. And then, as these tasks build up and the metadata associated with those tasks start to build up, you need to start thinking about your data infrastructure much more carefully, like where am I storing it, how am I storing it, how do I version it, how do I add metadata, how do I do so, there's a good paper by Neil Lawrence at Amazon called Data Readiness Levels, which is how do I understand how many different sorts of data I've got and how ready they are to be built on top of, right? Ultimately, you want data that is down here at the kind of gold standard ground truth level. I think in the paper he does it a bit like TRL levels. So he's got kind of 3 tiers, A to C. A1 being gold standard ground truth that you can build on top of straight away. The sort of C4 being, well, we think we collect it and we think we know it's in the business somewhere, but we don't really know who knows, or we think it's in that filing cabinet. We think it's in the filing cabinet. We could go and do OCR on it if we needed to. If there was a court order or something, if we had a freedom of information request, we know we've got the data, but we don't really know what state it's in or where it is. And any business is going to be littered with these different types of data from these different types of applications. Some of the system process data will be very well curated. It'll have tests against it in terms of checking its integrity. And then there'll be a whole load of stuff that the business still relies on, which is basically in filing cabinets and people's notebooks even. So one thing to do is, after you've had a look at the application layer and you've had a look at the tasks and you've started to sort of micro-prioritize some of the tasks you might look at, you might go down to the data layer and start to produce a data manifest and have an idea about what sources of data and the quality or standard of that data exists. And then in your MVP, ultimately you might not even need an engine, because you might just game it with people to begin with. But let's pretend you've got enough good labeled data for a supervised learning problem for this particular task. You could build an engine, and you can decide whether it's something that's already, let me skip down a layer. We can decide whether it's something that's consumable by a utility service. It's already on a cloud, G Cloud, AWS, Azure. It's a sort of standard random decision forest or something, or whether actually you are up at the kind of, I need to build this for myself. This is the first time, right? Or you're in the middle, which is, well, we know we need it, and we might have to turn it into something that we build going forward because it's critical to our business, and we think it provides differentiation and a USP, etc. But in the interim, we'll buy it from a startup or a company and see how it works and see whether we can integrate it. Because most of the heavy lifting is not to do with the engine itself, right? It's to do with the integrity of the data and the interfaces and the human processes and the application layer, right? In terms of business process management, what do people do, right? This is the fun bit, which we talked about for 3 weeks, but it's really not the heavy lifting, right? The heavy lifting is all sort of transformational, organizational, standard stuff. And you can decide. So this is how you make a transition from this kind of task layer into being able to consume commodity services, which is to be able to transform your domain problem at the top of the graph into something that's well understood, well behaved, easy to consume, easy to solve for. Right? And when you first do it, you might not understand enough about the problem, and it might look like it's a kind of novel, interesting, difficult, we could spend a lot of R&D money on this. Right? But the sooner you get into the knots of the problem and try and transform it into something that is commodity, standard inputs, standard outputs, standard system requirements, in terms of sort of cloud provision, then obviously the cheaper it's going to be going forward, the more useful. And then there's basic stuff, which is really, ignore the engine layer. Most companies have just got basic, cloud infrastructure stuff still to do, right? In terms of getting all the systems onto REST APIs and having a schedule for migrating stuff to, lower value compute. So this is the sort of beginnings of my recipe. How much time? Oh, I've got no time at all. Nice. We're supposed to be doing questions. So I saw Mark slide in the back. So I'll speak for another 10 minutes, but we won't go through the case study. I'll sort of go to the conclusion of the case study, and those of you who are interested can read through it because there's a chapter online. So this is from AI Nation. I will put this up before I share it. I've forgotten the name of this book. It's quite good. It's by a guy who was chief of staff for one of the big Chinese internet companies. And this is his sort of 5-point chart to really becoming an AI first or a machine learning first type business. Which, when you read it, sounds a little bit trite, but it is basically the best summary I've come across, right? So, instrument everything. Most things aren't instrumented. Like, the whole reason why the app economy took off is because instrumentation on smartphones is easy. But telematics in businesses where you wouldn't think telematics historically played any role is quite important. So you put all of your assets online, in terms of tracking inventory, tracking, even tracking people. Put sensors somewhere, right? If it requires someone to go and do something to check a state of the world, put a sensor in there so that you can check the state of the world without the person. This is where a lot of the heavy lifting gets done, right? To understand decision-making chains, you need to understand your value chains. So you do your mapping exercises and figure out where the pain points are. Get data flowing. Follow Jeff Bezos, only in lag by 10 years or so, and turn everything in the business into an API, so that you can look at flow between components of the business. Never throw anything away. So this comes back to the data thing, right? Most of the business problems that you're going to come across are not going to have the correct metadata for the sorts of problems that you're trying to solve, because no one ever thought it was important enough to store it somewhere. So get into the habit of cycling through metadata storage and try and keep everything. And this fits into sort of, again, standard IT type migration upgrade scenarios in terms of data warehouses and data lakes. And then, last but not least, apply some algorithms. Easy stuff, right? Covered it in 3 weeks. So that's where we got to. Then I seem to have done a lot of talking. I was going to talk a little bit around getting truth data, getting labeled data, getting metadata labeled, different types of weak supervision. This is probably the sort of state of the art for trying to bootstrap kind of supervised learning efforts. Thinking about ways of doing different supervision. This is worthy of a lecture in its own right. But one of the things that we did cover earlier when we thought about transfer learning, for example, was data augmentation, right? How do we generate additional data for these very large network type scenarios so that we can build it? This is a sort of trivial example with the digit. So we get the original data and we want to be able to create more data that's useful. So here we provide some transformations so that our training set contains a whole load of different types of sixes, but that in a business context, that might be, if this is a sort of a non-temporal dependent event, can we permute the set of events we've got over hours in the day so that we end up with 20 times as much data for this type of thing or whatever it happens to be. Got to be a little bit careful with that. I'm going to skip over this stuff. Lots of interesting things. I guess I'll return to that next week at the beginning. I'll just introduce the case study. So we already saw the business, which was an analytics engine for dealing with cooling and data centers. This was a contrived story until DeepMind's first commercial product was an engine for monitoring, for reducing energy consumption in data centers. This one project, I'm led to believe, saved Google in 1 year more than the cost of DeepMind, which they bought for 400 million. So it's not a bad return. So return on investment was in 1 year, which basically takes the amount of energy that the data center is using, turns on a reinforcement learning algorithm. This is when it's turned on, so this is being automated control as opposed to manual control or current system control. This is when it comes on again, so you save a lot of energy. So you work for, the case study is you work for a company that produce a product that to do this sort of thing. And the strategy is around what you should be doing over the next 5 years or so, 3+. And there's some data on there about some marketing data in terms of sales and new clients. You've got sort of forecasts. You've got a business model canvas at a level. Look, this is the same data that I showed you on that original map, right? So from that, you can construct your first graph because it's all done it for you. And pretend you're in a board meeting. Pretend you're thinking about the strategy of the company going forward. What do we do with it? And we're presented with a few different options. We can start doing some sort of cloud-based services. I won't read through the whole thing. I'll set it up for you. And in the MBA class that do this, we do this over sort of 4 hours, and we role play it. So they go away, they get given some data, come back with your scenarios. So everyone comes back, and they're going to build a cloud strategy. And then we say, well, have you thought about this in more detail? So we give them a bit more data and the P&L, and asked to evaluate some options. And then we say, right, you vote on what you're going to do the first time round, then we start to build a map, and we look at the structure of the map, and we look at some of the dynamics in terms of the markets and the competitors entering, and where there may or may not be innovation around the automation of parts of this, either collection of data or the sensors themselves. And we think about some of the inertial forces, and we think about some of the game plays, right? We talked about ILC as a data-enabled business pattern for marketplace and app ecosystem models. And our US competitor has a sort of commoditized, cheap product that they're now using to leverage people building on top of. And what do we think about the strategy? And I'll skip over it. But ultimately, we start to have this idea about where we should be spending our time. And I'll flick and I'll ignore this bit. And so then we can start to evaluate different possibilities, right? Do we try and go into a new emerging market? Do we try and build a new product around the availability of new data that we've been collecting? Do we try and replicate the US effort in terms of building a ecosystem model for our particular kind of data product? And I will I'll stop. I won't tell you the answer. Then you'll have to go and read it. And then we could discuss the answer next week.